Hi there, in this video I'm going to show how to do some advanced setup of InspectJ. No need to be worried here, InspectJ's default setting is good for the majority of images. But, of course, with the very many different kinds of images in the scientific world and elsewhere, it might be nice to custom tailor the analysis to your needs. This software is open source, so if you are a programmer, feel free to take it and do with it whatever you want. You can extend or modify it, or you can just take parts of it to use it somewhere else. We'd be happy, that's completely up to you. But if you do not have a background in programming, this video will show you how easy it is to change the important features of InspectJ. If you look at the software, the first problem might be where to find the piece of code that's relevant to you. Well, that's easy. Just have InspectJ open in either ImageJ or, as you can see here, in Fiji. Press Command and F on a Mac or Control and F on a Windows system. And just type the word Advanced, or if these are too many characters, just type ADV and click Find Next or OK. Now, with every click, the program will jump to the next piece of user-relevant code. It's the lines in between the asterisks I'm talking about, as you can see here in the Fiji script editor shown in green. Well, if you are doing it this way, you will sure not miss out on any code important for key parameters and general settings. Okay, let's start. InspectJ is based on the idea that multicolor assignment to the intensity values of an image will significantly improve the detectability of possible image manipulation. These colors come from so-called lookup tables, which provide the mechanism to transform a range of input intensities into another range of colors. Simply put, the more colors there are, the better the inspection with InspectJ will work. InspectJ and Fiji come already with a range of lookup tables. If you don't like the default one, just go ahead and do what is shown here. Go to Image, Lookup Tables, and choose whatever lookup table you like. I can only recommend to test a few and check how the color assignment looks on your image of choice. Once you have found one that works for you, simply remember its name, here it is 16 colors, and type it into the InspectJ code. It's that easy to change the color assignment. Okay. In InspectJ, an image is displayed like a movie, showing different color, threshold, and intensity settings. Here, in the general settings, the user can set up many things regarding the movie. For example, how many shades of color you want to see, or how fast the movie is supposed to run, and should all performance features of InspectJ be displayed or not. In addition, size and shape exclusions can be set to include or exclude objects from the inspection. And there's more. So let's quickly go through the code with the common numbers 0 to 15 here. Number 0 is the minimum and number 1 is the maximum pixel intensity of the intensity range. For standard use of InspectJ, it is recommended to keep these numbers as they are in order to ensure best performance. Number 2 is the number of steps along the intensity range. In other words, here you decide how many shades of color you want to see. The higher the number, the more shades you'll see. But the movie will run longer. Number 3 is the millisecond delay of the color displays along time. Obviously, the smaller the interval, the shorter the time span to appreciate an image display. The larger the interval, the longer the movie will run. Number 4 simply defines which key to use to pause the InspectJ run, which is by default the spacebar. Number 5 is the time interval in milliseconds in between display routine steps. So this is not the time in between changing color displays as in number 3. No, this is a time interval in between different performance routines. Number 6, the background setup should not be changed if you are not an expert programmer. Number 7 is the millisecond delay after detection of a key hit by pressing the Shift key to stop the InspectJ run. If you experience any responsiveness problems with the Shift key, please try different millisecond delays. Number 8 allows you to decide which routine step InspectJ will perform. If set true, 3 steps, effective brightness contrast, threshold levels, and threshold types can individually be selected. If set false, InspectJ will run all three automatically. Number 9 and number 10 restrict the objective areas in the clone analysis to be in between these two numbers. Areas below the minimum size and above the maximum size will be excluded. Number 11 and 12 act very similar to number 9 and 10, but here with respect to circularity, not area size. Circularity values range from 0, which is an infinitely elongated polygon, to 1, which is a perfect circle. Number 13 defines which key to use to stop the InspectJ run, which is by default the Shift key. Number 14, if set true, will run additional feature displays exclusively running in Fiji and not in ImageJ. If set false, InspectJ will not show them at all. If number 14 is set true, setting number 15 true will make individual selections of the features activated in number 14 possible. Okay, that's it with the general settings. Please play with them and test them on a copy of your InspectJ software. As part of the clone analysis in InspectJ, it is possible to freely set the selection parameters and the tolerance values for the identification of identical objects. Here you can see that 5 parameters were chosen, and the tolerances were set to 0% for all parameters of the default analysis and 5% of the second analysis with customizable tolerances. And you can see the results based on these particular settings. So how can all these settings be changed if you like to use your own ones and not the default entries? It's actually quite easy. Have a look. Here's one way to show how to do it. Open the image to analyze and have ImageJ or Fiji and InspectJ open. Go Image, Threshold, and test the thresholds in the Auto Threshold drop-down menu. Once you have found an automatic threshold that works nicely on your image, simply remember the name and write it twice into the software as shown here. After that, go to Plugins, Macros, Record, and move the recorder window out of the way. Next go Analyze, Set Measurements, and check the measurements you would like to use for the clone analysis. Here, just as an example, I go with area, mean gray value, and shape descriptors. OK, upon having set the measurements, the corresponding line of code has been recorded by the macro recorder. From there, you can just copy the text and paste it twice into the software as shown here. Then, do a test measure to see the results table. This is not to do any measurements at the moment. No, this is just to see the number of columns. Please count them and make sure to have the same number of entries written in your software code as shown here. That's all. I hope I managed to convince you that it's really not that complicated to do some advanced setup of the software. Okay? Please check the other videos on InspectJ. Thanks for watching and cheers from the ZMBH imaging facility.